Hello, everybody. My name is Zach Bodi. I am a student in the College of Arts and Sciences studying computer science with a minor in deaf studies, and I'm here today to talk to you about sidewalks. Accessible city sidewalks are critical for individuals who use mobility devices, such as wheelchairs, to safely go about their day-to-day lives. Yet, a simple walk through the city of Boston reveals endless flaws in its sidewalks. Unfortunately, no comprehensive data about where accessible and inaccessible sidewalks are currently exist, which poses two additional challenges. First, it forces wheelchair users to learn through trial and error which areas are accessible to them, which puts their safety at risk. And the other is that for the city to fix these problems, it has to know where they are. But currently, it relies on an antiquated system of 311 reports where people have to report individual problems with individual sidewalks for the city to know where they are at all. Of course, this leaves most hazards completely unaddressed. The aim of my project has been to take steps towards addressing these challenges by automating the process by which we can record and classify information about sidewalks. The underlying problem is of great personal importance to me because my boyfriend is a wheelchair user, and so this affects his safety. A year ago, before I started this project, there was an incident where his wheelchair caught on a crack in the sidewalk, launching him forward out of his chair, hitting his head on a brick, giving him a concussion, and a welt the size of a tennis ball on his forehead. My hope is that my work and future work on the topic can help to prevent incidents like this. The basic idea of my project is that I took a wheelchair and I attached a camera to it and I pushed it all around the city recording footage of sidewalks. Then I used a process called machine learning to create a computer model that can go automatically from an image of a sidewalk to a classification of what type of surface that sidewalk is between concrete, brick, and asphalt. The purpose of this is that then you can give the wheelchair to a bunch of volunteers, have them push it all around the city, recording footage along with GPS data, and then use that data in my model to automatically generate a map of sidewalk surface types throughout the entire city. The reason I decided to focus on surface types specifically is threefold. The first is that it provides inherent value for wheelchair users. For instance, my boyfriend hates trying to navigate brick because there's random snags and it becomes a hazard. The second is because if you want to do something more advanced, like classify surface damage, it helps to be able to first classify surface type, because damage to brick versus to concrete, for instance, looks very different from each other. And the third is that it has very clear ground truths, meaning you and I both know what concrete, brick, and asphalt are, so it's very easy to evaluate the accuracy of my model. Now, in order to understand how my model actually works, first we have to talk about machine learning. Machine learning is essentially the process of programming a computer to teach itself how to do something, a sort of artificial intelligence. To illustrate that, imagine I have millions of pictures of cats and dogs, and I want to separate them into cat pictures and dog pictures, but I don't want to do it by hand. I could use machine learning. The first step would be to take a few thousand of those images and manually separate those by hand. That process is called labeling because I'm giving it a label of cat or dog for each image, and the data I get is called training data. Then I would create something called a neural network. Unfortunately, I don't have enough time to go into all the technical details, so you can think of it as a magic math box that takes in an image, it looks at the colors of the pixels of the image, and then does a bunch of random calculations to come up with what is at first a completely random, meaningless probability, but we can arbitrarily call the probability that the image is of a cat. So maybe I put this dog into it, and then it says there's an 83% chance it's a cat. That's not very helpful because it's of a dog. But imagine that there are these sliders on the box, and each one controls the strength of one of the calculations that the box is doing. So maybe I move one of these sliders, and now it says there's an 87% chance that it's a cat. That's even worse. That didn't help. But what if we take a step back, and for each slider, we go through individually, and we move it just a little bit one way or the other to see which improves the prediction. Well, if we do that for all of them, maybe now it says it's an 80% chance it's a cat. Well, that's a little better than 83%. But imagine that I do that thousands of times with the thousands of images in my training data. The hope is that over time, the sliders would converge into a position where now the math that the box is doing isn't random anymore. It's actually calculating the probability that this image is of a cat. That's effectively how my model works, except instead of a few sliders like you see here, it's millions of sliders. And they're not actually sliders, it's numbers that the computer is changing automatically versus me moving something. So the process of actually creating my model is after I recorded this footage, I went through 800,000 images of sidewalks and labeled concrete, brick, and asphalt sidewalks. Then I went through that training process I just described, where it made incremental improvements by moving those little calculations, the strengths of them, until it got better and better and better at predicting, until eventually it stopped improving, and then that's when I stopped it and said, this math box is my final model. Important note is that when I did that, I only used 80% of the data that I labeled so that I could use the other 20% for evaluation later. And what I found with that evaluation is that my model was 95% accurate, meaning 95% of the time when my model was predicting an image, it would assign the highest probability to the correct surface type for that image. 95% sounds great, and it is, but it's even better when you think of it in context of the problem. Sidewalks don't go concrete, brick, concrete, brick. They're like continuous segments, at least for a little while. So you could probably do some work when you're mapping it with geographic averaging over smaller segments of sidewalk to kind of get out some of the outliers and hopefully bring the accuracy a little bit above 95%. Now, that's all well and good, but there is a long ways for this to go because surface type is useful information, but it's not a complete solution. For that, you would want to be able to classify surface damage, width, incline, presence of curb ramps, all kinds of things. Luckily, using the footage I already collected, you could do exactly that. And so in interest of that, I'm handing over everything I've done to BU Spark, which is a tech incubator here, and they will hand it off to another student or group of students who want to continue this work. But in a broader sense, I hope that my talk here today can inspire some interest in using technology to tackle accessibility challenges. I think there's a lot of work that would be really helpful and really cool that could be done in that space that has yet to be done. In light of that, if anyone here today is interested in getting into that type of work or wants to know more about what I did, please feel free to email me. This is my email here. And I believe I have a couple minutes for questions. Thank you.
Fantastic work.
Hello, great presentation. Can you speak a little bit about the process through which you trained your model using your training data?
Sure. So the actual process, because a lot of this is like automated in terms of like the sort of sliders that I talked about, right, on the box, those get moved automatically. So the things that I'm sort of deciding on are how long is it training for, I make some little tweaks to like the actual math that it's using inside. There's also the amount that you're moving that slider, right? Do you want like a big jump each time or do you want little jumps? Because little jumps make it less kind of error prone, but also can cause it to get stuck at like local minima, right? So like things that seem like they're pretty good, but if you made a bigger jump, you might be able to get out of that. So it was a lot of just tweaking that and seeing what increased and decreased the accuracy of the final model. Thank you.
Zach, could you expand on your final comment about the possibilities of technological solutions to accessibility challenges? How do you see the general landscape? What are some other developments that you're excited about?
Sure, that's a great question. I think a lot of them have yet to be imagined, but I mean, just going about my day-to-day life, right? In my interactions with my boyfriend, there's accessibility obstacles that I never would have thought about prior to, living my life with him and seeing all of those things firsthand. And then I'm like, oh, I could design this thing in CAD and 3D print this thing to, and I think there's a lot of things you could potentially come up with, whether it be like physical tools for various accessibility challenges or other things that are very synonymous to this, worth using computer vision to help, map different things or things like that. I think there's a lot of innovations that could be done there that have yet to be imagined.
I have a similar question.
Sure.
I gained an entirely new appreciation for these challenges when I became a stroller user, and ultimately didn't even want to push the stroller through Boston streets. It was far easier to carry babies. So one of the applications that I'm imagining would be tremendously useful is a kind of mapping tool where you could determine where, if you're a wheelchair user, where you would want, the path you would want to take through a city like Boston. Is there a way to translate the data you have into something like that? Absolutely.
So I think that was part of what I was originally imagining when I was dreaming up this project is, okay, if we got to, and it has to go a bit further than it's at, right? Surface type isn't enough. But if you were to make additional classifiers and get a better general view of just accessibility of a segment of sidewalk and you have that mapped through the entire city, then, I mean, you could easily make an app or a plugin for some other map application that instead of just doing your new normal Google Maps route through something, labeling, it will map that based on accessibility of the route, right? Because right now, I mean, we even have things that are like telling you where to drive to get somewhere faster based on the traffic movement, right? You could easily do something like that if you had a good map of accessibility of those areas.
That's amazing. I want it.
Thank you.
Other questions? No. Sir?
Love this presentation. Just to get a better understanding of the scope of how much machine learning can help with labeling these things, I was so curious as to know how long did it take you to manually label all those, I think, 800,000 photos of sidewalks?
Yeah, so I had to be a little bit clever about how I went about labeling them. I wasn't going through and like doing every single one by hand so much as what I was doing, because like I said, it's continuous segments for a while. So I made myself a little like script that would show me things, and then I could like hold the C key and it would just rapid fire through a bunch of images and label them as concrete. So I had to get a bit clever in that way, but there's also ways that like there's a variety of services that you can like sort of crowdsource this sort of labeling, whether that's you're going to pay a small amount of money, you know, per image for people to do that, or if it's something, I mean, if it's something like this, I'm sure there's a lot of people who would be willing to go through and just do 100 images just as a volunteer because they like the work you're doing. And so I think there's a lot of opportunities there. And there's also a lot more work being done into how you can do these sorts of things while not labeling all your images. That's called unsupervised learning. It's where you're just sort of seeing what the computer can garner about the images and how it might be able to like cluster them right into groups without you identifying what those groups are.
Thank you so much.
Thank you. Thank you.